So in these examples, we'd want to verify if the ordered pairs that we have correspond to the equation that is given to us. The equation here is y equals 3x minus 5. Now, every single ordered pair must satisfy the equation for us to say, okay, an ordered pair is on a particular equation or would satisfy a specific equation. So what I'm going to do, we know in a coordinate pair, the x value is the first number and the corresponding y value is the second number. So we will plug in x is equal to 0, which would imply y is equal to 3 times 0 minus 5. I get negative 5. So I should get positive 5, but I end up getting negative 5. So 0,5 does not belong to y equals 3x minus 5. The next point is minus 1, minus 8. So the value of x is negative 1. The value of y is negative 8. So we plug in x is equal to negative 1. We get y equals 3 times negative 1, negative 5. We get negative 3, negative 5, which is negative 8. So minus 1 minus 8 belongs to the equation because when I plug in x is equal to negative 1, I get y equals 8. So here is another function which kind of looks funny. So y equals 2 bars and x is right in the middle. So that is what we call the absolute value of x. And this is the absolute value function. I'll call it equation for the time being. What does an absolute value mean? So if I have absolute value of positive 2, I get 2. If you plug in negative 2, the absolute value of negative 2, is positive 2. So no matter what value you plug in for x or a number inside the absolute value, you would end up getting a positive number. So we have to verify the two coordinate pairs that we have. So the first pair is minus 1, 2, which would imply x is negative 1 and y is 2. So we plug in negative 1 for x. Since it is an absolute value, the negative 1 would become positive 1. So I get 2. So when x is negative 1, I end up getting y equals 2. Therefore, minus 1, 2 belongs to y equals 2 times the absolute value of x. The next pair is 0, 2. X is 0 and y is 2. We should already know the answer because we know, according to the equation, when x is -1, y is +2. So this cannot be true, but you could plug it in to verify. So y would equal to 2 times the absolute value of 0, which is 0. So when I plug in x is equal to 0, I get y equals 0. So 0, 2 does not belong to y equals 2 times the absolute value of x. Here is another function, which is y equals x cubed. Anytime you have a power like this in the exponent, it's best to put it within parentheses. I recommend to put parentheses if you have negative numbers, parentheses if you see powers. This way you wouldn't make any mistakes. So the first coordinate pair that we have is 2, 8, which would imply x is 2 and y is equal to 8. So if I plug in x is equal to 2, I must get y to be equal to 8. So y would be equal to 2 raised 3, which is simply 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, and it works. So 2, 8 belongs to y equals x cubed. So the next ordered pair is 3, 9. This would mean when x is 3, we must get y equals 9. So y would be equal to 3 cubed. 3 cubed is 3 times 3 times 3, which is 27. So when I plug in x is equal to 3, I end up getting y equals 27. So that is not the pair we have. So 3, 9 does not belong to y equals x cubed. As a side note, I could write 3, 27 belongs to y equals x cubed. And why is that? If I plug in x is equal to 3, I would end up getting y is equal to 27. So 3, 27 will belong to the equation. So all we have to do is plug in the values of x and see if we get the value of y back in order to determine if a coordinate pair satisfies a given equation. The last case here is an equation. We have negative 6x plus 5y equals negative 6. As far as mathematics is concerned, we like to have y on one side and the x's and the numbers on the other. That is a standard way to express a function. So what we have here is minus 6x plus 5y equals minus 6, which would mean 5y is minus 6 plus 6x. I'm adding 6x to both sides. So minus 6x plus 6x plus 5y equals minus 6 plus 6x. Those two would go away and I'd end up getting that. An easier way to look at this is I'm moving negative 6x from the left-hand side to the right-hand side. Anytime you cross the equal sign, you have to flip the signs. So if you have a negative 6x, if it moves to the other side, it becomes positive 6x. If you have positive 6x and if it moves to the other side, it becomes negative 6x. I'm going to divide this equation by 5 on both sides. So 5y over 5 equals minus 6 over 5. When we divide, we have to divide every single term by 5. So the 5's would go away. Y would equal to negative 6 over 5 plus 6x over 5. So we have two ordered pairs. So the first pair is 1, 0. In other words, if x is equal to 1, y must be equal to 0 for 1, 0 to belong I'll say to satisfy the given equation, which is negative 6x plus 5y equals minus 6. So if I plug it in, I would get y is equal to minus 6 over 5 plus 6 over 5 times 1 minus 6 over 5 plus 6 over 5. Those two would go away. I get 0. So when I plug in 1, I get 0 for y. So 1, 0 does belong to the equation. So it is a solution to the equation. So belonging to an equation is the same as saying a solution to an equation. Next we have 2, 6 over 5. So is that a solution? So this would mean x is equal to 2 and y is equal to 6 over 5. So if I plug in 2 in the equation, I must get 6 over 5 for y, and if it happens, then it is a solution. So y would be negative 6 over 5 plus 2 times 6 over 5. So we have 2 of 6 over 5, and we are taking away 1 6 over 5, so the answer is in fact 6 over 5. So when x is 2, y is 6 over 5, it satisfies that condition. So 2, 6 over 5 is a solution to negative 6x plus 5y equals minus 6. That is 2, 6 over 5 belongs to minus 6x plus 5y equals minus 6. Belongs simply means it will take on that particular value. So just by looking at it, we could say we can identify the quadrants. 0 and 5, both of them are positive, so that is in the first quadrant. Negative 1, negative 8, both values are negative, so it is in the third quadrant. X is negative, y is positive, second quadrant. Both values are positive, first quadrant. Both x and y are positive in both of those pairs, so first quadrant and first quadrant. Here it is the same thing, first quadrant and first quadrant.